Assalamualaikum warahmatullahi wabarakatuh. My name is NURHAKIM. Today I want to talk about laboratory safety. First, when we enter the lab, we should wear our mechanical jacket, which is red color. Then we should wear goggles and safety shoes. Okay, in a lab, we should never eat and drink or smoke in a lab. Second, do not run in lab. Third, do not come near operating machine because it will be dangerous to us. Okay, fourth, do not leave any running machine unattended. It is because to avoid any dangerous happen and accidents. Okay. Fifth is in any case of injured or any case, we should contact our instructor immediately to help you. Okay. Sixth, take off all accessory because if to prevent you from severely injured if our accessory stuck in the machine. Okay, thank you.
I am ABDUL TAMAT. Okay, today I will explain about binary caliper. In the first lab, we do experiment about metrology. So we all must to measure the workpiece in lab sheet. So in binary caliper, the function of the binary caliper is to measure the small workpiece. In binary caliper have part. The first part is internal jaws. Internal jaws is to measure the small diameter such as hole or slot. Second is internal jaws. Internal jaws is taking offset measure such as diameter, length of piece. And next is main scalar. Main scalar is the measure along the caliper. So the main scalar is graduated by inch or millimeter. So next is vernier scalar. Vernier scalar is small scalar to get accurate measure. Next is depth measure blade. Depth measure blade is to measure the depth of hole. Okay, and next is locking screw. Locking screw is the function. The locking screw is to lock the measure and you can remove the binary caliper and taking the measure. The last part is the thumb screw. The function the thumb screw is to adjust measurement of the space on the caliper and help to user to tight grip on measure. Thanks all from me. Thank you.
This is the third part. We do bench work, which is this is the workpiece before the bench work and this is after. All the process including involving filing, which we have to file here, here and here. For us to remove this part, we have to drill first, then we use hammer to remove this part to get this shape. To make this line, we use seesaw. So that we need to saw this Before that, we have to mark using marker, whatever marker is it. Then saw it using the seesaw. This is for this hole. We have to drill it first, then use the hand tap to make thread. The first one is we use hand tap number 1. The hand tap look like this, and it has thread over here. Then we put this inside this, and we rotate it inside the hole so that the thread will be visible inside the hole. After that, we use hand tap number 2, and the last one is hand tap number 3. So that the hole is done, the thread is done. So the bench is done. Thank you.
So today I'm going to talk about the last part, which is we go through machining. So before we go deeper in machining, we must know the cutter material. Therefore, we can avoid any accident which can make the cutter broke because of the wrong using speed. So first of all, we need to know this table. So this table show the cutting speed. This is 80 to 100, 20 to 30, 10 to 18, and so on. So this is the cutter material, mild steel, and other else like aluminium, copper, and brass. So for this case, we just only use carbide, which is mild steel, start from 80 until 100 cutting speed. So we go to the calculation. So we need to know the RPM first. So by the cutting speed, we can get the RPM. So cutting speed is times by 1000 and divide by pi d. So from there we can get the RPM. So for this case, we just use the minimum cutting speed is 80. So 80 times 1000 divided by pi times 30. So we get 880 RPM. The RPM. So next we go to the step during the machining process. So first process is facing, and then turn down, and then the last process is drilling. So first process is facing. Facing is mean you shorten the workpiece to your desired measurement, which is this measurement. Absolutely, it's 100. So by facing step, you can cut off from rectangle workpiece into a quite certain line. Okay, this is facing. This means that you reduce the excess of the metal. And then turn down. Turn down is absolutely to make your diameter smaller. So this is your diameter. This diameter we must make into 30. This one is 30. Yes. So if you want to make 30, you can make turn down, which is it's cut the diameter by 1 millimeter per rotation. So if you get firstly, if you get your diameter 40, right, and then you want to turn it into 30 diameter, so you need to reduce 10 millimeter. Okay, and then we go to drilling, the last part. So this is drilling, which you make hole inside the workpiece. So drilling process is the last process, and it's also not really hard to do. You just get RPM first, the correct RPM, and then you just drill by the cutter that is applied to you. Okay, that's all for the last part, which is machining. Thank you from me.